Hey guys, Mrs. Kaufman here. How are you? Okay, let's go ahead and get started by doing the Common Core quick check. Go ahead and answer these problems. There's the answers. How are symbols such as less than, greater than, and equal to useful? Today we're going to learn to represent functions using words and equations and to show them in tables and graphs. So one of the key concepts is to represent functions using words and equations. So the words, for example, in this one are a runner's distance in a marathon is equal to 8 miles per hour times the number of hours. So when we say words, it's kind of like a word problem that we often see. And the equation then that we figure out from those words is d for distance equals 8t. We're going to learn to represent functions using tables and graphs. So, for example, in this table, we have in 0 hours, we go 0 miles. But in 1 hour, we'll go 8 miles, and in 2 hours, we'll go 16 miles. And then that is shown in the graph. If you notice over there, you go over 1 and up 8. You go over 2 and up 16, and so on. And so we'll be graphing some of the things that we find in our functions now. Okay, so for example, the drama club is holding a bake sale. They are charging $5 for each pie they sell. Write an equation to find the total amount earned, T, for selling P pies. I want you to notice there are two variables in this equation, T for total amount and P for pies. So in the words, total earned equals $5 times the number of pies sold. Okay, so the total earned is 5 times the number of pies sold, because every time they sold a pie, they made $5. The variable then, we're going to let T represent the total earned. We're going to let P represent the number of pies that were sold. Our equation then is T is 5 times P, or let's say the total that we made is $5 per pie, okay, or times pi, or times P really. Okay, so the equation is T equals 5P. Remember, we talked about how in algebra we don't always include the little dot because it's not necessary and it takes up more space than we need. Can start to get confused with a decimal. We don't use the x because that can be confused as a variable, and so we just write 5p. T equals 5p, and mathematically speaking, we want to say t equals 5 times p. In a science report, Mia finds that the average adult breathes 14 times each minute when not active. Write an equation to find the total breaths B, a non-active person, makes in m minutes. In words, it says, let B represent the total breaths and m represent the total number of minutes. The total number of breaths equals 14 times the number of minutes, right? We read that there, 14 times each minute. So the equation is B equals 14m. So this is like useful if I want to say, well, if you breathe 14 times for every minute, how many breaths would that be in, say, 5 minutes or something? So that's when that's going to become a useful thing, when I need to determine how much it would be if there's more. Okay. The student council is holding a car wash to raise money. They are charging $7 for each car they wash. Write an equation and make a function table to show the relationship between the number of cars washed, C, and the total amount earned, T. Okay, and we've done function tables several times. You know how we make the 3 rows like this, okay? So that's what we're talking about. Using the assigned variables, the total earned T equals 7 times the number of cars washed, C. So the equation is T equals 7C. So right here, this is where we've been doing our equation, T equals 7C. The total earned output is equal to 7 times the number of cars washed. Did you see this? 1 times 7 is 7. 2 times 7 is 14, because that's how many cars we washed. If I washed 1 car, they give me $7. I made that much money. When I wash another car, I get another $7, and so on. So after I've washed 4 cars, I've got $28. So we're going to write 7C, or 7 times C, in the middle column of the table, because that is our function. The student council is holding a car wash to raise money. They are charging $7 for each car they wash. So we're going to graph the ordered pairs. Yes, we just did this on the previous screen, and we're going to use that kind of same information to help us graph the ordered pairs. So you're going to find the ordered pairs of C and T. C being the number of cars and T being the total amount of money that we made. So the ordered pairs are 1 and 7, 214, 321, and 428. I'm just going to hop back to that last screen so you can see it again. Here we have 1 and 7, 2, 14, 3, 21, 4, and 28. That's where those numbers are coming from, in case you weren't aware. So let me get back here. Okay, so now we're going to need to graph those on the graph. So we're going to go over 1 and up 7, over 2 and up 14, over 3 and up 21, and over 4 and up to 28. Okay, and now what we're going to do is see if it's linear. Do they go in a line? Yes, they follow a line, because the amount increased by $7 every time the car is washed. Or a car is washed, not the. So how did what you learned today help you answer our essential question? How are symbols such as less than, greater than, and equal to useful? There's a sample answer, if that helps you think about it. Okay, here's your ticket out the door. Describe how the concepts in the earlier lesson on functions and equations helped with today's lesson on multiple representations of functions. Okay, so you are done with your whisk, or you need to start your whisk rather. So go ahead and summarize and write a question. So some of you have been asking, what do I write here if I'm not confused? That's a great question. What I want you to write for the question portion is a word problem. Create a word problem based on what we've done. Something that you can solve, or one of your classmates could solve based on what you've learned. Thanks, guys. I hope you have a great day.